Hey y'all, Data Guy here. And today I wanted to kind of make a video just really as an intro guide to someone who might be new to the space of cloud computing and just wants a quick explainer on what cloud computing is, why it's so prevalent in every industry these days. No matter what company you're in, you're likely using some form of cloud computing, and just give you an idea of all the basics, the terminology, how everything fits together, advantages and disadvantages, so that you kind of get a sense of hey, this is a really compelling new area of technology. Obviously, it's been around for a while. It's not going anywhere. It's only going to continue to grow. I mean, the age of on-prem databases and mainframes like, from IBM and Oracle are going the way of the dodo. It's just going to happen. It's going to be a slow death. You're going to have those organizations that are going to fight it for as long as possible, but eventually everyone's going to be on the cloud. And I can say that with a good amount of security. So enough of me waxing poetically around, kind of what I think about cloud computing. Now let's get into some actual definitions of what cloud computing is. So in general, you have cloud computing is really just a paradigm that allows users to access computing resources like servers, storage, databases, software, analytics, networking, whatever, over the public internet. Or private internet, depending on your security configuration. There's a lot of people that use the private internet to connect to cloud resources. And this really offers faster innovation. You don't have to actually build or buy the resources, install the software yourself. It's flexible. You can get rid of or acquire resources as needed, and it gets you economies of scale. And the economies of scale I'm referring to are for the cloud providers, like Amazon or Google, that are able to get these big bulk discount deals, buy all this server spaces, build these massive data centers, and then they're able to sell that computing space at a premium to you because they're able to get it for so much cheaper because they do it at such a large scale. So they're able to acquire that compute cheaper than you as an individual would be able to do it typically. And then these companies rent access to those users as people need them. So the advantage for the user is they don't have to own or maintain their own computing infrastructure, but they do need to constantly be paying for it. Um, and at its core, cloud computing really relies on virtualization technology. And virtualization refers to the ability to create a virtual instance of a resource, like a server or a storage device or a kind of smaller version of a compute from a single physical hardware base. So what that means is, let's say you have one big server that is running, a ton of CPU power, a ton of RAM, and you're actually splitting that server into smaller virtual instances. So, let's say you have a server that has 100 CPUs, right? You can then create 50 smaller compute nodes that each have two CPUs on them. And they're all logically isolated, which means while they aren't on different servers, there are networking paths and compute paths for each compute node runs as its own self-contained unit. It's effectively like you installed Windows on a portion of that server. Obviously, this is a really simple example, but that's kind of like the base concept of what virtualization technology is. And that's what is referred to when people talk about virtual machines. It's the ability to segment a single server that has a large amount of compute into many smaller virtual machines. Then each one of those virtual machines can run its own operating system, it can run its own applications, and it really makes it functionally equivalent to a physical server. And then the cloud providers' data centers, the AWSs, the Googles, the Azures, they host just millions and millions of these servers, and then can provide these resources to just tons and tons of different customers and make those billion-dollar line items and get to the trillion-dollar valuations. And so there's a few different models for cloud providers. So there's infrastructure as a service, which is just providing that base compute layer, saying, hey, I need the ability to run a Kubernetes cluster. I don't want to run the Kubernetes cluster on my own hardware. I want to run it on Amazon's hardware, and I just want to be able to interact with that compute power to run my applications. That's what infrastructure as a service is. Platform as a service is really when it's a full service platform. When you have that's something like a Azure Data Fabric. It is a full platform for developing things. Its platform refers to, or an Informatica, where you have a data governance ETL, all kind of an everything platform rolled into one there. That's what that's referring to. And then SaaS software as a service, that's your Snowflakes, that's your Astronomers, that's your Databricks. Those are companies that are really focused on, a single area, single software product where you're typically interacting with that through, graphic user interface over the internet. Um, and so those are kind of the three different buckets, fundamental compute, development environment, and then application software. And then on the other side of things, so the way you're deploying your clouds also differs. So really regulated banks, really regulated industries, they'll typically deploy on a private cloud. And what that means is that you actually have your own separated servers that aren't running any other company's work. So AWS says, hey, you're big Goldman Sachs, you're going to run on our private cloud, and their softwares that are running your products aren't going to be running anyone else's, and you're completely logically or completely isolated physically. There's no access to the public internet over those resources. It's completely walled off and secure. You also have hybrid or public cloud, which is the opposite of that. It's shared resources, logically isolated, so separated by code, not by physical infrastructure separation. And that's what the majority of companies will use, especially startups. That's where if you just log into AWS and you deploy a resource, that's the public cloud. And then hybrid just refers to a kind of mishmash of both of them together. And that's what a lot of organizations will do because some resources can't be put on a private cloud. And so they'll kind of use a hybrid cloud architecture to keep the secure things secure and things that can be used on the public internet, able to connect them in a secure way. So now why has cloud computing become so popular? Number one, cost efficiency. It is way more cost efficient to use cloud computing to rapidly spin up infrastructure. It eliminates that capital expense of needing to buy and then maintain that hardware and software, running data centers, paying for servers, electricity, cooling, IT experts, database admins. It is extremely expensive to run your own data centers. And so cost efficiency that cloud computing provides just makes it a no-brainer for most organizations. It also enables a really high degree of scalability because you're able to, just with the push of a button, provision or deprovision resources. You can scale almost perfectly elastically to the needs of your businesses, which means you deliver the right amount of IT resources right where it's needed. So more computing power where it's needed, more storage right when it's needed, without the need to kind of like provision a bunch of infrastructure and just have it sit there until it's needed. Also performance. These massive cloud companies are constantly optimized and they run on a worldwide network of secure data centers, regularly upgraded, regularly brought up to the next and latest generation of fast and efficient computing hardware. And these are performance gains that if you want to implement in your own data center, it's going to be an insane investment. And you get all these performance benefits just by, obviously paying that monthly charge to AWS or whoever. And again, speed and agility, the ability to provision resources in minutes, spin up a whole new data stack in a day, and just gives you really, you obviously still need to do capacity planning, but it takes the kind of risk off capacity planning. Or hey, if I misalign the capacity for how many databases we need, we'll just buy more, and they're available almost instantly. And then finally, reliability, data backup, disaster recovery, business continuity is much easier and less expensive because you can mirror data at many different redundant locations on your cloud provider's network without needing to support those different locations physically by building a data center in Jakarta or something. So now that we've talked about the reasons why it's become prevalent, I also want to talk about the advantages and disadvantages of cloud computing. And I'll start with our advantages here. Number one, flexibility, scalability, and that kind of competitive edge that you get with that flexibility and scalability. If you have a business with fluctuating or growing, bandwidth demands, you're constantly bringing new customers, or you're a seasonal business, cloud computing just gives you a unprecedented degree of flexibility that businesses before couldn't access. You also have much better data security and disaster recovery. Obviously all businesses should invest in disaster recovery, but smaller businesses might lack the required cash, the expertise, and it's a big burden on a small and growing team. So it's more often an ideal rather than a reality to have your own kind of data security plans. And so cloud, by just having data security and reliability and disaster recovery baked in at the core, allows these small organizations to implement better cloud or better computing practices and become more secure. Also, cost savings. Obviously, I've said it once, I'll say it a million times. You're going to save a lot of money. Typically, if you're going from like a big on-prem data center to the cloud, you can still spend a lot of money on the cloud. I'm not saying that. I mean, there's all those horror stories about AWS bills, but the it's a lot more manageable. You're not just going to like unless you're really negligent, it's unlikely that your costs are going to get out of what you would expect them to be. And also, just complete abstraction away the management of that infrastructure. It is completely off premise, out of sight, out of your space. Your suppliers take care of them. They roll up upgrades. They keep them secure. They make sure they're running on the latest and greatest hardware and software. And it really just requires you to just plug and play. There's no thinking about the infrastructure. It's just using infrastructure for actual business purposes. However, with all these advantages, there are some disadvantages. You do have the risk of downtime or vulnerabilities, even though these organizations do have some of the best and most secure networks in the business. There is always a risk, and so there can also be compounding just like malicious actors. There can be the risk of an outage. Your AWS region might go down, and well, yes, there's disaster recovery things in place. Like I've run in a situation many times where an AWS region goes down and it really impacts businesses. You can't really do anything about it. It's just saying, hey, you got to wait for Amazon to fix whatever went wrong. Sometimes there's a flood in a data center and a data center goes down. Like that's real world coming to play with business there. And so, that you do have those kind of risks of business interruption because of events that are really outside of your control. That's part of the risk of giving that control to a third party entity. And then also kind of part and parcel with your limited control and flexibility and also vendor lock-in, it's going to be difficult once you've kind of made the shift to a certain cloud provider to move between clouds. Typically, you'll kind of feel locked in on like, hey, now that I'm in AWS or Azure or Google, all my infrastructure should be in one of those clouds. And so it's just very hard to break free once you kind of are in that state because you have to move over so many things and the connectivity as you're moving things over it's not amazing between clouds. There's definitely gotten better over time, but still the best connectivity is between resources in the same cloud. I think I found, and then vendor lock-in or yeah, so vendor lock that and then you don't have the same degree to customize the resources to do things that might be a little bit more kind of edge use case when you're relying on cloud products because they are just kind of a one size fits all approach. Now, finally, when it comes to cloud providers, there are only three clouds you really need to know, and that are AWS, Amazon Web Services, Microsoft Azure, and Google Cloud Platform, also known as GCP. And these are all companies I won't spend too much time on them. They all kind of have their own different language, but you'll generally have, if you look on the left here, a few different like core services, the ability to deploy Kubernetes, deploy Dockerized applications, serverless computing, development platform, virtual servers, some object storage like S3 buckets, archive and file storage, and then content delivery network for hosting data and information, and then also a managed data warehouse as well. Redshift, BigQuery, SQL Warehouse, and each cloud they just have their different names for kind of the same services. There's I would say close to service parity between the three clouds. It's just a matter of kind of how the UX is and what kind of UX you prefer, and also which cloud your company prefers. Some companies really like Azure, some companies really like Google Cloud, some companies really like AWS. They all have their kind of own different quirks and kinks. And there are other cloud offerings out there. They're not worth even talking about. These are the big three. I've never seen any of the other cloud providers in production. I know IBM and Oracle have cloud providers. I used to work at Oracle. Their cloud sucks. I haven't touched IBM's cloud and I've never actually seen it. So only need to know these three. And yeah, that's kind of my end of my intro guide to cloud computing. Hope you found this video useful. Let me know if you'd like me to kind of continue this cloud computing exploration anywhere else. But otherwise, have a great rest of your day. Data Guy out.